I think you were quite familiar with the differential equations because that you did at your plus 2 level. Everybody did differential equations earlier at plus 2 level?
Yes, ma'am.
Yes,
Yes.
ma'am.
Okay. So you have some idea about the differential equation. However, here you have applications of both difference and differential equations. So first, we want to understand, or it will be best to understand, what is the difference between difference and differential equations. Both the structures are, both the difference and differential equation framework are dynamic framework. Dynamic framework means here we will incorporate the time element in our analysis. So far, when we discuss the micro models, we mentioned that we are considering a static framework. That is a particular time point. However, as days changes, we move from 1 month to another, we move from 1 year to another year. Actually, prices, test preferences, all these things changes. So time is an important factor in the entire analysis of micro and macroeconomics. So we have to incorporate the time element in our analysis. Now we can consider the time as discrete time. That is first period, second period, third period, so 1, 2, 3 like this. This period may be a week, this period may be a day, hours, months, years, etc. However, we are considering between the first and the second time period, there will be no change. There will be change will occur only at the terminal points. That is, when I'm starting from 0, the same growth rate or interest rate, everything will be, tax rate will be continued up to the first period. Then there may be a jump in the first period. Then between first and second, there will be no change. Change will take place coming at the point 2, or again the change will take place coming at point 3, etc. So as if between 0 and 1, 1 and 2, 2 and 3, everything remains unchanged. So this notion is called the notion of discrete time. Time is changing like 1, 2, 3, 4 like it. Between 1 and 2, there will be no change. Between 2 and 3, there will be no change. Now, in case of discrete timing, we cannot apply calculus. We cannot apply techniques of calculus because for applying calculus, that is for applying differentiation technique or integration technique, we need a continuous variable. Now, if we give some steps, at first point, there may be a jump. In the second point, there may be a jump. Third point, there may be a jump. And between 1 and 2, no change. 2 and 3, no change. In that case, actually, the concerned variables are not continuous in nature. Now, if the variables are not continuous in nature, in that case, we will be not able to apply calculus. And therefore, we will be not able to use differential calculus and or integral calculus, and for that matter, differential equations. Okay. So we have to solve the problem algebraically. We have to use algebra to solve for, time path of price, time path of income, etc. So this will be a dynamic concept. However, the entire concept will be covered using algebra. We will be not able to use calculus. So you will find that conceptually there are many similarities between difference and differential equations. First of all, both the models are dynamic models. In both the models, time is very important factor. Okay, and we are talking about CF, pi, similar type of terminologies as we use in case of differential equations. Can you tell me what is CF? Anyone can remember? Complementary function. Pi is particular integral. Can you remember all these terms and terminologies?
No, ma'am.
You didn't do these things at +2 level, Shubha?
Ma'am,
No,
I
ma'am.
guess no.
No, I guess no one did
No,
this.
ma'am.
No,
No,
ma'am.
ma'am. Did not
No,
have
No,
ma'am.
these
ma'am.
class two.
Okay.
We do not know these
Okay,
terms.
no problem. Okay, no problem, no problem. Okay. So when we will solve the things, so we will learn the new things. Okay, no problem. So when we will use the terms and terminologies, you will find that the things are very, very similar. However, because of discrete nature of the variable, in case of difference equation, we will be not able to solve anything using calculus. We have to solve everything using algebra. Whereas when we will move for differential equations part, or when we will move for the continuous time part, we are using the calculus and solving everything using the differential equations technique. Now, continuous time means between 0 and 1, 1 and 2, every time there will be change, So, continuously the variable will be able to change. Okay. So, please note down, in case of difference equation, we consider the time to be discrete in nature. DISCRET, discrete in nature. Whereas, in case of differential equations, we consider the time to be a continuous variable. We consider time to be a continuous variable. Okay. So with this basic idea, let me start applications of difference equations. Just a minute, I need to present it. Is it visible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so we are starting to discuss difference equations and its applications in case of economics. I'll start with a numerical and then I'll move to the specific economic cases. Next. Okay, so I'm starting with a numerical. So would you please write down the equation yt plus 1 minus 5yt is equal to 1. And you also add y naught is equal to 7 by 4. Y naught is equal to 7 by 4. Now this is called a first order difference equation. Okay. Why difference equation? Because I'm considering time to be discrete. So I'm getting a model with 1 period lag. I have the values of the variables for the t plus 1th period. And we have values of the variable y for tth period. Okay. So if T is equal to 1. Say we have data for the second period and we have data for the first period. That is, we have data, say, for 2020 January and we have data for 2021 January. Okay, number of COVID cases. Y is, say, number of COVID cases. So number of COVID cases in January 2021, that is YT plus 1, and number of COVID cases in January 2020, which is YT. The equation is YT plus 1 minus 5YT is equal to 1. Now, why this is a first order equation? Because there is one period lag. If I consider two period lags, in that case, it will be the second order equation. If we increase the number of lag, we can move on and on. We can consider 10 period lag. We can consider 5 period lag. Okay. And the length of the lag will determine the order of the difference and differential equations. This rule is same for difference and differential equations. So if I consider 5 period lag, in that case, it will be the fifth order difference equation. 2 period lag, second order difference equation. 1 period lag, first order difference equation. So the given example, I hope you are understanding, is a first order difference equation.
Ma'am, what is the lag? Like, how is it?
Lag is the gap between the periods. Gap between the periods. Okay, the lag is the gap between periods. Here, I hope you are finding it is T plus 1 and T. So gap between the two things are is one period. The gap between the two periods is one period. Okay, so this is a first order difference equation. Are you understanding time lag, the notion of time lag?
Yes,
Gap
ma'am.
between the periods. Okay, instead of this, if I write, T plus 5 minus, if equation is like this, there is a, another change. In Tth period, you are getting a value, and then there will be a change after 5 periods. So you have information on YT plus 5. So after the 5 periods, coming to the 5th period, starting from Tth period, you will have the information. That is, you have information for 1990, 95, 2000, 2005, 2010, 15, 20. If the information is like that, in that case, there is a lag of 5 periods in the variable Y. Okay, so in that case, we have to form a fifth order difference equation. And it's not necessary that only YT plus 5, there will be value for YT plus 5 and YT. In between, we may have the value for YT plus 2, YT plus 3, etc. So that may be a longer equation. That is YT plus 5 plus, say, 2 into YT plus 3 minus 3 into YT plus 1 minus 5YT. So the equation may be like that. Okay. So this is the basic idea of time lag and how we will define the order of difference and differential equations. Now, why we are learning these things? What is the background? The background is we need to find out the time path of economic variables. Time path of national income, say, how over time the national income has changed. Okay, what is the trend, what is the exact time path, etc. What is the time path of price? What is the time path of savings? What is the time path of investment, rate of interest, tax? So time path we want to study. Okay, whether the time path is monotonically increasing continuously, it has increased over time, monotonically decreasing continuously, it has decreased over time, or it is increasing in one period, decreasing in second period, increasing in third period, decreasing in second period, cyclical. Okay. Now, if it is cyclical, when we are getting this kind of cycles, whether over time the path is moving towards equilibrium or it is moving away from equilibrium, or it may happen that it is neither moving away from the equilibrium nor it is coming towards equilibrium, we are getting uniform oscillations. Okay, so let me draw this. Okay, so I'm giving you some ideas. Suppose I'm considering this for price, okay, and suppose this line is the equilibrium price. The notion of equilibrium remains unchanged over time. Equilibrium is a notion which is static in nature. Actually, here we will use the term intertemporal equilibrium. Over time, an equilibrium value. So suppose this line is giving us the equilibrium value. So it may happen that it's, just a minute. Suppose I'm drawing the time path of price. This is time. So these values are periods, 1, 2, 3, etc. Typically, I'm considering discrete time. And you are getting, between the periods, there is no change. Coming to the first period, there is a change. Then unchanged. Then coming to the second period, there is a change. Then unchanged, etc. Okay. So this is monotonically increasing time path of price. This variable may be price, this variable may be income, anything, any economic variable, savings, rate of interest, etc. Okay, and I'm considering in this diagram, I'm considering this level, that is this 0th level, as say equilibrium. So here we are getting that time is over time, the price is moving away and away from equilibrium. Okay, so it is basically monotonically divergent time path of price. Okay, it is moving away and away from the equilibrium. So here it is going up. You may consider the diagram like these two. Okay, this is also monotonically divergent time path. Here it is, moving away and away above the equilibrium. Here it is moving away and away below the equilibrium. That is the only difference. Here the starting point is above equilibrium. This point here, the starting point is below equilibrium. That's the thing. However, both are the diagram of monotonic time paths. monotonically divergent time path of price. Okay, so this is one idea. Or
Ma'am, is the second graph monotonically decreasing?
monotonically decreasing, yes.
Ma'am, is it necessary the equilibrium value will stay constant?
Yes, it is necessary. I'll come to the mathematics, I'll come to everything. Equilibrium remains constant over time. The concept is equilibrium. The notion of equilibrium remains unchanged. Okay, so we have to measure whether it is there is a change in the positive direction, negative direction, fluctuations, etc. Equilibrium, the notion of equilibrium in a particular economic context will remain unchanged over time. Is necessary, yes. Okay, so sorry. This is another possibility. Can you tell me what is the difference between the first one and this one?
It is moving
This is
closer
convergent.
to
Convergent towards equilibrium.
Yeah. So the only difference is the earlier one was divergent, whereas these two are monotonic, however convergent, because these are the path is moving towards equilibrium. So this is one variety. This is also monotonic, however it is and remember here we are measuring time. Okay, so all these things are basically time. 1, 2, like this. And these are P naught, this kind of thing, initial price from where it has started. Okay. So this is one concept. Another thing, these are only the rough work, so you may draw it or you may not. Here, suppose this is the starting point, starting price, say. So it has come down to the equilibrium. Then it is again moving up. Then moving down. Moving up. Etc. Okay. So I hope you are understanding there is a difference between the time path which we considered earlier and this one. This is oscillatory. Okay. It started from this position and then in the second period went to this level, then coming up to this level, coming down to this level, coming up to this level. And not only that, while it is moving up and down around the equilibrium value, continuously the gap of the price with respect to the equilibrium that has changed. If you look at the thing, you know, this length is greater than this length. Okay, the down length. Again, the up length is lesser than this down length. then this down length is lesser than this up length, and so on. Okay, so it's not only oscillating, it's not only giving us the idea about the fluctuations around the equilibrium, it is also telling another thing, it is convergent. So we can call it damped oscillatory, damped oscillations. Okay, the reverse also may happen. Suppose we are starting from this point. Length is increasing here. Length is further increasing. Coming down. Moving up. Okay, and so on. So what type of path is it?
Divergent.
Oscillating but divergent.
Oscillating with divergent.
This is divergent, definitely, very good. We call it explosive oscillations. Okay. Explosive oscillations. And finally, another possibility is there. So, sorry. Same length. It is neither moving towards equilibrium, nor it is moving away from equilibrium. This is uniform oscillations. Okay, uniform oscillations. So actually, our objective to learn these chapters is to find out the time path, how inflation has changed over time, how the price is changing seasonally, how the interest rate is moving up and down or monotonically increasing or decreasing over time. So we need to learn all these things. We need to understand, or we need to derive the time path of economic variable, how an economic variable is changing over time, whether there is a cyclical changes, whether there is a seasonal change, whether there is a trend kind of thing, monotonic path, etc. Okay, so we are coming back to our first order difference equation, yt plus 1 minus 5yt is equal to 1, where why not? I hope you are understanding why there is an information regarding the historic starting period. Why not? Not maybe, anytime. It may be 90 years back, it may be 5 years back, the starting point, In case of pandemic, this particular pandemic, if you consider the starting point, that is, December 2019. That is the starting point, Why not value? Now, when we will try to solve this kind of difference equation, there will be two aspects. One aspect is the complementary function, CF. We need to derive the CF. Another part will be the particular integral part, which is equivalent to equilibrium value of the variable. Okay? So, there will be two parts. One part is the complementary function. CF. Another part, which is equivalent to okay. So this we call PI. Now the time path of a variable is equal to CF plus PI. Okay, so if my concerned variable is Y, and we need to find out the time path for Y, we actually need to solve this equation. Yt is equal to CF value plus PI value. If I want to find out time path for price, again from the model, we have to solve for CF path and PI path, and final time path will be given by PT is equal to the CF component plus PI component. Okay, so both the components are very important to derive the time path mathematically. So we need to learn how to derive the complementary function part for the concerned variable and how to find out the equilibrium value of the variable or the PI part of the variable. So first we will learn how to find out the complementary function part. To do the complementary function.
Can you show the previous slide once more?
I didn't get you.
Can you please show the slide once more, the previous slide just once more?
This one.
Yes, ma'am.
Okay. Okay, we will come to these things. Okay, again and again.
Ma'am, can I
Complementary.
tell once more about YT and PT, the difference?
Y is one variable, maybe income variable. P is another variable, maybe price variable. If you consider S generally we use for savings. If you use capital I generally we use for investment. Okay, so all these economic variables, Y, P, S, I, if you consider small r, generally we use it for the interest rate. If I consider small t, generally that is used for tax rate. So all these things, all economic variables. For the particular numerical exercise we have started to consider, I am not telling y is any economic variable because we first need to understand how to solve a difference equation and thereby how to generate the time path for a variable. And then we will apply this technique. To find out the time path of economic variables, income, price, rate of interest, savings, investment, tax, whatever economic variables will come in our future days, or already you learned about several economic variables, we can apply, the technique for each of the economic variables. Got it?
Yes, ma'am. Thank you.
Okay. Now let's concentrate on complementary function part. How to derive the complementary function given a difference equation. And we are first considering the first order difference equation. Later we will understand about the higher order difference equation. So we have started with a very simple case, which is a first order difference equation. That is, we are considering a maximum lag of 1 period. Maximum lag of 1 period. Okay, now to derive the complementary function, we have to consider the homogeneous form of the given equation. What I am telling? To derive the complementary function, we need to consider the homogeneous form of the given equation. So complementary function, which is the general solution of the reduced homogeneous form. What is the homogeneous form? The constant part will be equal to 0. So the equation is yt plus 1 minus 5yt is equal to 0. Okay. All variables with time element will be there, and the constant part we have to consider to be equal to 0. Actually, we will bring all, in this case, all economic variables are in the left hand side. So yt may be on the right hand side. I could write the equation as yt plus 1 is equal to 1 plus 5yt. So to write the homogeneous form, I'll bring all variable terms to the left, all time bound variables to the left, and in the right hand side I have to put 0. Okay, so complementary function is basically the solution of the reduced homogeneous form yt plus 1 minus 5yt is equal to 0. And if you want to find out the solution for the non-homogeneous form, that is for the equation which is given, in that case, along with the complementary function, I need to derive the particular integral. And I have to add the complementary function with the particular integral. Okay, so I mentioned, now I am concentrating only on the CF part. So I am not considering the non-homogeneous given equation. Rather, I have to consider the reduced homogeneous form of the given equation, because CF is the solution to the reduced homogeneous form of the equation. Is this sentence clear to all of you?
Yes, ma'am.
Yes, ma'am.
Everyone tell me, because we are finding, the teachers who taught you last semester, there are some issues, some problems in understanding of few students, So there is no problem if I mention the things thrice, 4 times, 5 times while I am teaching this thing. No problem. So those who have any kind of problem, any problem in understanding, please be vocal and ask me. Okay. Now, for this reduced homogeneous form, or to solve this reduced homogeneous form, we have to consider a trial solution. A trial solution. The form of the trial solution is the variable value for the current period equal to a b to the power t. So we consider yt is equal to a b to the power t. Now, if I consider any economic variables as savings, in that case, the equation will be in terms of the s variable. And I have to write ST is equal to AB to the power T as the trial solution of the homogeneous form. So this is the common thing. You can consider any economic variable. However, this trial solution will remain AB to the power T.
Excuse me, ma'am.
Yes.
Ma'am, this trial solution, how we are finding? Means, is it this AB to the power T is for first order or for common all?
It is for, first order, second order. We will solve for second order, third order, etc. So first you concentrate only on first order. When we will go for the higher order, you will get everything. So first you try to understand how the first order difference equation can be solved. Don't mix up with many things, because you are learning the things for the first time. Okay?
Ma'am, so this AB to the power T, this is the general trial solution of homogeneous form.
General trial solution of the homogeneous form. We
Okay.
don't use the term general, we use trial solution, trial solution for the homogeneous form.
Okay.
Okay. In some books, you will find that instead of B, they are using exponential E. Actually, when we will go for dynamic model, we will form this trial solution in a bit different way. However, here we are doing this thing algebraically. So the best way to learn this thing is to consider AB to the power T. I'm not using exponential because that is unnecessary complications. Okay. Therefore, consider a very simple structure where the solution is AB to the power T. Yt is equal to AB to the power T is the trial solution of the homogeneous form. Now, if you look at the homogeneous form, there are two y variables, yt plus 1 and yt. So if I need to find out the values of these unknown elements A and B, both A and B are arbitrary constants. So if I want to find out the values of these A and B, using the values given in the equation, I also need to write the trial solution for yt plus 1. So, if yt is equal to AB to the power T, yt plus 1 is nothing but AB to the power T plus 1. Thus, the homogeneous equation can be rewritten in terms of the trial solution as AB to the power T plus 1. I'm replacing yt plus 1 by AB to the power T plus 1 minus 5 yt I'm replacing by AB to the power T is equal to 0. Then I'm taking AB to the power T common, and that is into B minus 5 is equal to 0. Since AB to the power T is a trial solution where A and B are arbitrary constants, naturally the trial solution will not be equal to 0. Otherwise, we will be not able to solve anything. Hence, B minus 5 will be necessarily equal to 0 here. And from there, we can solve for the value of B, which is given by 5. As we get B is equal to 5 for this particular problem, the complementary function can be written as yt is equal to a 5 to the power t. I am calling this equation number 1. Now look at the things. If anyone has any question for the first order difference equation, the way we derive the value for B, please ask me. Any question? We will solve for A later. We need to solve for A too. We will solve for A later. Before that, we will derive the other component which I mentioned, particular integral, and which is equivalent to the equilibrium value of the concerned variable. Sorry. So another element is called particular integral, which is the general solution of the non-homogeneous form yt plus 1 minus 5yt is equal to 1. So CF was the general solution for the homogeneous form. Now I am considering the solution for the non-homogeneous form. Let yt is equal to ye be the intertemporal solution for this non-homogeneous form. Now what is meant by intertemporal? The term intertemporal indicates over time. Over time. So yt is equal to ye is the over time fixed value for the non-homogeneous form. Intertemporal solution. So over time solution for the non-homogeneous form. So in place of yt and yt plus 1, we are writing ye because it is the intertemporal truth. In t plus 1 period, equilibrium value of the intertemporal solution is ye. In tth period, the intertemporal solution is ye. So it remains unchanged. Over time equilibrium, across different time periods, the equilibrium value remains unchanged, or intertemporal solution remains unchanged. And from this equation, we get ye is equal to minus 1 by 4. So, the general solution, which is sum total of CF and PI, will be given by yt is equal to yc plus ye. Now, yc is a 5 to the power t. And ye is minus 1 by 4. So equation 3, which is the general solution for the time path of y, is yt is equal to a 5 to the power t minus 1 by 4. In equation 3, everything we are finding in terms of the values of the variables given in the original equation apart from the factor a. In other words, in equation 3, the only unknown component is a, arbitrary component. So we need to derive the value of a. How we will derive it? For this, for solving the value of a, we need to set yt is equal to y naught. So historically given starting point we have to consider to derive the value for a. So we are rewriting equation 3 as y naught is equal to a minus 1 by 4. Y naught value is already given. I hope you can remember at this moment because I shifted this.
7 by 4.
7 by 4. Yes. So this 7 by 4 I have used. 7 by 4 is equal to this. And from there, we are getting the value of a, which is equal to 2. So I'm calling this equation number 2. Okay, sorry, equation number 4. Sorry, equation number 4. So, if I like to write the final form of the time path of the concerned variable, So the time path, that is substituting the value of A in equation number 3, substituting 4 into 3, we get yt is equal to 2 into 5 to the power t minus 1 by 4. And this is the required final solution. I told you the final solution is CF plus PI. Okay, and we solve for every unknown factors in CF. So the required time path of the variable y is given by yt is equal to 2 into 5 to the power t minus 1 by 4. Okay. So first tell me whether you are understanding how to derive the time path.
Ma'am, could you please show the previous slide?
If I adjust this thing, okay. From this slide, we are getting the value of A, and that we are putting here, and we are getting the time path yt is equal to 2 into 5 to the power t minus 1 by 4. Any question regarding this slide? Anyone? And then finding this value. Someone told me to show this slide. Is it okay now?
Yes, ma'am.
You know, in case of differential equations, etc., the first step will be to derive the time path of the concerned variable. So the first part is complete, derivation of the time path of the variable. Then there are two more things. First of all, whether the path is moving towards equilibrium or over time it is moving away from the equilibrium. That is, whether the time path is convergent or whether the time path is divergent. If the time path is convergent, in that case, the equilibrium is dynamically stable. Because if you start from off equilibrium, over time, you will come towards equilibrium. Asymptotically, the value will merge with the equilibrium. Okay? So, if the time path is convergent, the equilibrium is considered as dynamic stable equilibrium. Starting from off equilibrium position, someday a time will come when we will move towards equilibrium. On the other hand, if time path moves away from equilibrium, it is the divergent time path. In that case, the equilibrium is dynamically unstable. Equilibrium is dynamically unstable. So what I am telling, if the time path is convergent, equilibrium is dynamically stable. If the time path is divergent, in that case, equilibrium is dynamically unstable. So we need to find out answer to this question first. Yes, we got the time path. However, whether this time path is convergent towards equilibrium, that is, whether the equilibrium is dynamically stable, or time path is divergent, in other words, whether the equilibrium is dynamically unstable. So this will be the question. And finally, we need to answer to our last question. If it is convergent, whether it is monotonically convergent or it is oscillatory convergent or damped oscillation. If it is divergent, whether it is monotonically divergent or we will get explosive oscillations or uniform oscillations. Okay, so nature of the time path. So first we have to assess whether the time path is monotonic or, sorry, whether the time path is convergent or divergent. And then we have to check whether the time path is monotonic or oscillatory. Okay, now matching the four conditions, convergent, divergent, monotonic, oscillatory, we need to finally comment on the nature of the time path. Okay, so there are multiple possibilities: monotonic convergent, monotonic divergent, oscillatory convergent, oscillatory divergent, uniform oscillations. So all 5 possibilities are there. Okay, so this will be the second part of the analysis. Okay, so first I will cover the part to understand whether the time path is convergent or divergent, or the time path provides a dynamic stability or it provides a dynamic instability. Now please concentrate on this equation. Yt is equal to 2 5 to the power t minus 1 by 4. Now if you can remember, this minus 1 by 4 is nothing but ye value. Everybody can remember this is ye?
Yes, ma'am.
Yes, ma'am.
Okay, fantastic. So yt is equal to 2 into 5 to the power t plus ye. Agreed?
Yes, ma'am.
Yes, ma'am.
So equilibrium will be dynamically stable if yt tends to ye as t tends to infinity. Equilibrium will be dynamically stable if yt tends to ye as t tends to infinity. Is it okay?
Yes.
Yes, ma'am.
Yt is equal to, say, a b to the power t plus, this is the thing. Okay, I am telling is it acceptable? Time is moving, first period, second period, third period, and there is no restriction. So I'm putting it t moving towards infinity. So isn't it the definition of convergence?
Yes, ma'am.
Yes, ma'am.
So
Yes.
equilibrium will be dynamically stable if and only if yt tends to ye as t tends to infinity. I hope this is acceptable to all of you. Okay. Now, yt will move towards ye if and only if a b to the power t moves towards 0 as, sorry, t tends to infinity. Is it acceptable?
Yes, ma'am.
Ma'am, I did not understand this one. Acha, now I understand. Okay.
Okay, so yt tends to y. The previous sentence is telling equilibrium will be dynamically stable, or it will be convergent towards equilibrium if yt tends to ye as t tends to infinity. Now, if I want yt should tends to ye, this is possible if and only if the first component ab to the power t moves towards 0 as t tends to infinity. Okay. Okay. Given a is a constant, we got the value of a, 2. In our case, I think we got the value 2, isn't it?
Yes,
So a
ma'am.
Yes, ma'am.
is a constant value. So given a is a constant, a b to the power t will move towards 0 as t tends to infinity when absolute value of b should be less than 1. Is it acceptable? Now,
Yes,
if
ma'am.
it is a fraction, absolute value of b is less than 1. Suppose b is 1/3. So suppose you are first considering t to be 1, it is 1/3. Then square, it's 1/9. Then cube. So value is continuously reducing and reducing and reducing. So if you consider 1/3 to the power infinity, will it move towards 0 or not?
It will move towards.
Will it move towards 0 or not?
It will move
Yes,
towards.
ma'am. It will.
কারুর মনে হচ্ছে একটু কনফিউশন আছে, 0 দিকে যাবে কি যাবে না? ওকে, দেখো তুমি যদি if you consider 1/27.00 আসছে, now if you consider 1/3 to the power, ধরো suppose 50, the value will be so small, it will be too small, isn't it? If the absolute value is less than 1, that is if b is a fraction, in that case, as you increase the time period, the value will become smaller, smaller and smaller, and it will move towards 0. Now, given a is a constant, if b to the power t moves towards 0, the entire product ab to the power t moves towards 0, isn't it? If there is any
Yes,
question, please let me know.
Yes, ma'am.
All the steps are clear?
Yes,
So my
ma'am.
Yes, ma'am.
yt is equal to ab to the power t plus ye. I want to find out the stability condition. So equilibrium is dynamically stable logically if yt moves towards equilibrium as t tends to infinity. First line. Second step. Now this yt can move towards ye if and only if the first component ab to the power t moves towards 0 as t tends to infinity. Okay. Now, given the issue that a is a constant, ab to the power t will move towards 0 as t tends to infinity if and only if the absolute value of b is a fraction, is less than 1. Okay? So, either it will lie in between 0 and 1 or it will lie between -1 and 0. I'm considering absolute value to be less than 1. That means B will lie either between 0 and 1 or between -1 and 0. Everybody?
Yes, ma'am.
Yes, ma'am.
Okay. So are we then getting the stability condition? Can we write this?
Yes, ma'am.
Rest of the students?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Confirmed? This is the
Yes,
stability. If I
yes,
get
ma'am.
mod B less than 1, then the situation is stable. Then equilibrium is stable. In that case, we will find that the concerned value of the variable will move towards equilibrium over time. Okay, so here you will get all these things. Equilibrium will be dynamically stable if as t tends to infinity, yt tends to ye, which in turn implies ab to the power t tends to 0. Since a is an arbitrary constant, ab to the power t moving towards 0 when mod b is less than 1. That is either b greater than 0 less than 1 or -1 less than b less than 0. Hence, mod b less than 1 is the required condition for stability. Thus, the time path will be convergent towards equilibrium if mod b less than 1 and divergent from equilibrium if mod b greater than 1. Now, in this case, what is the value of mod b?
5.
5.
5. So, what will be the nature of time path?
Divergent.
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 Be divergent.
So,
Not
here the not dynamically stable because the b value is 5, mod b is also 5. So, we are not getting convergent time path here. For this particular example, we are getting divergent time path. Okay. So, answer to the second question done. First was find out the time path. Second was, is your time path convergent or divergent? Yes, we got the answer. We need to check the mod value of b in the trial solution. If we get the value to be less than 1, that path will be convergent. If it is greater than 1, path will be divergent. Third and final thing, whether your time path is monotonic or oscillatory. Monotonic or oscillatory. So let's go back to this board. Now, look at the equation. Yt is equal to ab to the power t plus ye. Now, if the b value is positive, look at the equation. If the b value, this b is positive, in that case, if you consider the t value, you know, it's moving like 1, 2, 3, 4, etc. If b is positive, always you are getting positive value. B square, b cube, b to the power 4, everything will be positive. Okay? Yes. Just a minute. আচ্ছা। Sorry. So what? Hello. বলো চটপট, আমি শেষ করিনি পড়ানোটা। থাকা তো দরকার দেখছি না কিছু। হ্যাঁ, সরি, না থেকে যাও, বিকজ ওরা আদারওয়াইজ ওই ফুড চার্ট, ডায়েট চার্ট এগুলো যেন করে দেয়, সেটা বলা হবে না, বলা। আচ্ছা। So once again, please look at the equation. Yt is equal to ab to the power t plus ye. So if b is positive, what I started to tell you, whatever be the value of t, even or odd, you will get a positive number. However, if b is negative, for the odd values of t, you will get negative value. For the even values of t, you will get this component to be positive. Okay. For example, if instead of 3, I consider this value as minus 1 by 3. Okay. So it will be first. Just a minute. So it will be like this, negative, positive, negative, positive. It will be like this for the even and odd values of t. So if you get negative, positive, positive, negative, positive, this kind of movement around this ye value, if this b is negative, in that case, around this ye, you will get a plus value, a minus value. again a plus value, a minus value. Okay, so against YE, your system will fluctuate like this. The positive value, negative value, positive value, negative value, like this. Okay. However, if B is positive, if this is the equilibrium, if the value is less than -1, mod value is less than -1, in that case, it will move like this. Okay. If mod value is less than, if mod value is greater than 1, in that case, it will move like this. Okay. For our typical example, when B is equal to 5, we get this kind of time path. Okay. However, in our example, if we could get that B is equal to -5, B is equal to -5, in that case, we will get oscillatory divergent time path. Because mod B is greater than 5, greater than 1, very sorry. Therefore, you are getting divergent. And since B is equal to -5, you will get oscillations. Okay. So the sign of B, that will determine whether the time path will be monotonic or whether the time path will be oscillatory. So I'm repeating, the absolute value of B will tell us whether the time path will be convergent or divergent. If the absolute value is less than 1, convergent, greater than 1, divergent. Next question is, what is the sign of B? If the sign is negative, in that case, for the even and odd values of T, we will get fluctuations around the equilibrium. So we will get oscillations. And if B is positive, in that case, we will not get any oscillations. We will get monotonic movement of time path. Okay. So sign of B will determine whether the time path will be oscillatory or whether the time path will be convergent. So coming back to our slide, the time path will be monotonic if B is positive. Time path will be oscillatory if B is negative. In our example, we get monotonic divergent time path of YT. Why divergent? Because mod B is greater than 1. Why monotonic? Because B is positive, 5. Therefore, the time path is monotonic. So this is the idea about how to derive the time path of a concerned variable for a first order difference equation case. That is how to find out CF for the homogeneous form of the equation, how to find out PI, which is equivalent to equilibrium of the non-homogeneous form, and then how to combine these two to derive the time path of the concerned variable. So this is the first part. Second part, check the mod value of B to confirm whether your time path is convergent or divergent. Third, check whether your B is positive or negative. If it is positive, time path will be monotonic. If it is negative, the time path will be oscillatory. So today I'll stop here. Do anyone have any question?
Ma'am, for uniform, is it -1?
For uniform, it will be equal to 1. Absolute value will be equal to 1. Yes, minus 1. Yes. No,
Ma'am, uniform oscillatory also.
yes.
-1.
For, no. For uniform oscillations.
Yes, ma'am.
For oscillatory, we need the negative value. And yes, that will be -1. Yes. Yeah. We will come to all of this, We will come to all of this. Check all these things. Okay then. Deepika?
Present, ma'am.
Or Panita will tell me, Panita and Kritika.
Yes, ma'am.
Who
Just a
are the
second.